Welcome to our lesson on some of the features of your new TI-89. I hope that as you go through this video you will pause each step of the way to repeat the steps on your own calculator, because it's only with practice that you'll start remembering some of these features. So much of your calculator is similar to your previous calculator. It might be new that when you turn it on you get a menu of options. This emulator, it just looks like a calculator, it isn't actually, is an older version. So you might have a version where you have to click on an application to get to the home screen or the graph screen. We also have a home button here whenever you want to get to the home screen where you would enter a basic arithmetic calculation. All right, let's get right to our directions. First, we want to set a couple things in the mode menu. So right above your variable keys, these are not alphabetic X, Y, Z, T. These are used for variables, a nice feature on the 89. Right above the Y is the mode key. So I'm going to draw your attention to two things. You can experiment with others here, but as we go down, the number of digits you want to display, you'll want to set to 12 if it isn't already. Notice anytime there's a side arrow here, you can go to your right arrow and it means there's a pop-up menu. So your calculator might be set to only display 8 digits, for example. So use your up-down keys to highlight the maximum, float 12 digits, and then hit enter. And then the other one we want to make sure, and you'll do this often, is that you're measuring angles in radians. In calculus, we'll always be using radians. Let me use the side arrow here so you see. In physics you might change to degrees, but then when you come to calculus, make sure that you change back to radians. So again, just use your up-down arrow to highlight. Enter to change the feature. And now when you've changed something in a menu, it doesn't save until you hit enter one more time. So make sure you never escape out of a menu. Make sure you always use the enter key multiple times so that your changes get saved. All right, in step number 2, we just want to practice in the home screen using order of operations and our 2 second keys. So notice that on each key of your calculator, there is a function above on the left side, and on my calculator it's in gold, so that I would use this second key to get to the gold function. And on the right side on my calculator it's green, and that would match this green key. So on a keyboard you would call these shift keys to get to the capital letters or the uppercase. So we want the square root, and you'll notice that the square root function is here above the multiply, so I need to hit the second key to get the square root, and the argument will automatically open with a parenthesis, so I want to put in 3136. So hopefully you can follow my cursor to the keys, and then we need to remember always to close the parenthesis, and the parentheses are right above the 7 and the 8. So close that parenthesis, and then our denominator will use the division symbol. And sign, not inverse sign, but sign is in gold. So above the Y key, I'll open the sign function. And 475, and then pi, we need to get to that second key again. And then we close the argument for the sign function. Oh, I guess that was a little too soon. Let me use the back arrow. I forgot the divide by 3. So this back arrow will delete. So I want to divide that by 3 and then close the sign function with a parenthesis. And now, I guess exactly what I didn't want you to forget, the denominator isn't finished. The denominator is a binomial. So I need order of operations. So let me use the left arrow key to get back here and insert an open parenthesis and then get back to the end. So maybe you learned something by my mistake. And then I want to add a +2 and close the parentheses. So clearly I wanted to remind you about order of operations. And we might not be sure whether we've done this correctly, but you will see how nicely we can read it once we hit the enter key, and it is written as a stacked fraction within a stacked fraction. Square roots look nice and easy to read. Exponents will be raised up. So we'll call this pretty print. And our answer here in exact form has a radical in it. This number might not mean a lot to you though, so I also asked you to approximate it, and you'll notice that in green above the enter key you can come up with an approximate answer. So without having to retype it, it stays in the entry line. So I hit the green diamond key, which gives us this upper approximate. So green diamond, enter. So now we have the answer in exact form, and now we've rounded that answer to decimal form. So I'm going to pause the video and transfer those into the blanks. So we can answer the next question there, put it in your notes so you'll remember. To get an approximate value, you will hit green diamond and the enter key. So if you put 7 divided by 9 in your calculator, it will come up with 7/9. So if you really want a decimal value, you'll get used to hitting green diamond, enter. There are other ways, by the way, to get approximate values, but green diamond, enter will always work. All right, next we're going to put a function on a graph. So we're going to go to the y equals or y editor screen. So we're going to use green diamond, F1 to get to our y editor, and we could put it into any of the functions, but as a note here, I've already got a function in y1. If I want to replace it, I have to use the clear button first. So you always have to clear the old function before you can put in the new one. So now as my function y1, I'm going to put 0.89 times the natural log. Here it is in gold above the x variable. So second key, natural log. And I think I missed there, so I'm going to back up. That's just a problem with my touch screen here. So let me try one more time. Getting a natural log, and notice it opens the parenthesis for me. And now I want the natural log of a cube root. So, and I just changed windows here. We'll get back to the calculator window. Somewhere like in this math menu, there is a cube root button, but I honestly never remember where it is. So I always just use fractional exponents. So I'm going to put another set of parentheses here, 0.89, and x is the variable, so it's nice and handy. We don't have to use an alpha key, and I only want that once, and then I'm going to use the exponent symbol, and I'm going to raise it to the 1/3 power in parentheses. So you can look for that cube root in one of the menus, and then I have to close my natural logarithm, and I might not be sure. Oh, and that's just my tablet repeating here. Doing this on a computer isn't very simple, so let me just use the back arrow to get rid of a couple of those, and let me see if I have this right. When I enter it, you'll be able to tell whether you typed it correctly when you read it in Pretty Print. It's certainly a nice feature, so we can tell right away if our order of operations worked the way we want. If I do zoom standard, so if I do this green diamond window, the zoom in the window, choices F2 is zoom features, and zoom 6 is the same as it was on your previous calculator. So zoom standard is zoom 6, and it graphs in a window from -10 to +10 on each axis. So we write it in interval notation this way, from -10 to +10 on the x-min, x-max, and -10 to +10 for the y-min, y-max. And now we want to change that, and it's a little bit hidden behind here. So I'm just going to drag my calculator for a minute to remind myself. So I want the y-axis. It's always x first and then y second. So I want to change the window size. So again, I'm going to go to green diamond. So I didn't want F2. Sorry, let me get back to my calculator and escape out of that. And let me do second window, and then I want to change my Y min to negative. Make sure you don't use the minus key, use the negative key, -1. And for the Y max, +1. And make sure it's entered. And then to go to the graph screen, green diamond graph. So you don't have to memorize these, but you will soon enough. And now my axis goes from -1 to +1 on the y-axis, but still -10 to +10 on the x-axis. All right, and then the next thing we want to learn how to do is how to find the 0, the x-intercept, and that, your friend, will become this F5 math menu when you're in a graph. So we do the F5 key to open up that menu. And choice 2 is to find the zeros. Remember, zeros of a function are its x-intercepts. And we'll hit enter. And there are 3 questions. The first one we don't have to do here because we only have 1 graph on our function. But if we had 5 graphs, then this is saying, do you want it to be y1, y2, y3, or so on? And you would use the up-down arrows to change that. You'll see that in a couple minutes on the next problem. And then the next question is move the cursor below the x-intercept. And there is only one x-intercept here, but think, for example, of a sine wave. You would have to say which of the intercepts are you looking at. So get your cursor just to the left of the x-intercept and hit the enter key. And then it's asking for an upper bound, so let's use the cursor to get above the x-intercept. And it'll say busy very briefly down here in the corner, and then it'll give us a 0. And here our y-coordinate turned out to be perfectly 0. Sometimes it might say, for example, 7e to the -15. Well, that's virtually 0 in exponential notation. That's 0.00000 and so on, 7. So it might be very close to 0. So this is our x-intercept. And I'm going to pause the video and write that in the blank, and then we'll scroll to move on to the next question. So I recorded all of the digits here, but if you have at least 3 decimal places, that will be our rule in AP Calculus, always at least 3 places. And then I'm going to pause to do one more thing here. We were asked to show a sketch. And the reminder here is that you always need to, your sketch doesn't have to be done nicely. You could see that that would be a good enough sketch. It's hard to draw with my tablet screen vertical. But what you need to show your test reader is what is your window size. So I can either label the x and the y axis this way to show the window, or like we did right here next to my graph, if you write 2 closed intervals, your test reader will always know this is y min, y max, x min, x max. So whenever you sketch a graph, show the scale of your graph that way. All right, now we want to find out what value of x is a solution to this equation. So I specifically made it a problem you wouldn't want to do algebraically. We couldn't, in fact, do it algebraically. So how can we solve to find out what x works? Well, there's many ways to do it on your calculator, but let's use a graphical method, and let's find out when the left side would match the right side by letting them be 2 different functions. So if we put the left side as function y1 and we put the right side as function y2, then wouldn't we simply need to find out where the 2 graphs intersect? So when we put these 2 graphs, when we put these 2 functions on a graph, wherever they intersect, that would be a value of x that produces the same y coordinate as the answer. And to save time here, we're going to use this value as the window. You might, in the future, you'll have to zoom in and zoom out and change the window until you figure out some good values. So it's not that it has to be that window. This is simply just for practice. So let me get my calculator open and turn on, and I'll go to the Y editor. And if you want to type in Y1, which you don't have to, you could go up to Y1 and leave it there and just use the F4 key to uncheck it. And then you could put your two new functions in y2 and y3. Or if I want to type over it, I have to hit the clear button first. So I'm going to do this one as 2 raised to the sine. We already found sine before of x is our exponent, and I'm not getting my keys in here. Let's see if I can get to, oops, it's being very picky. Second key, sine, there we go, of x. And I'll close that up and I'll check the pretty print. I always look to see that you entered it correctly. And then I want to put the right side. And I'm going to pause the video while I type that in. You don't need to watch me do that. Okay, so I think I have them entered correctly. And I could go look at the graph. The graph would be with whatever window I had before, though. So I might as well save time and right away go to green diamond window. And I want to set the window here to -1, 2 for the x min and max. Remember, it's always x's first when you write the two intervals. And then for the y min, I want -5. And the y max, I want 3. The scale and the resolution you can change. Where do you want the tick marks? How far apart? But I don't really care about that. So I'm going to enter this, and then I'm going to go look at the graph. So this is function y1 that gets graphed first. And here's function y2. Hopefully you knew that that cubic polynomial would have 2 turns in it. All right, and by the way, we had a sine function, so it would be very important that you're in radians, not degrees. And we have 3 different intersections, so we've got to practice this 3 times now. There are 3 different x values where the left side function is equal to the right side function. So now I want to find this intersection point. So I told you that F5, the math menu here in a graph, has all of your friends here. We're looking for choice 5, the intersection. So either scroll down or just hit the number 5 on your keypad. And then there are a few questions. You might have several different graphs. We only have 2. So if we had lots of graphs here, we have to first say, which 2 functions are you interested in? So is y1 one of the functions we're interested in? Yes, it is. So I just hit enter. And then the cursor jumps to y2. Is that the other function we're interested in? And it's our only function here. So yes, we'll hit enter. If we wanted y3, we would use the up or down arrow. All right. And now we are asked for a lower bound. So if I want to do this one first, I'm just using the left arrow to get below the intersection, just like we did for the 0. And I hit enter. And then I right arrow to answer the upper bound. And it'll be busy for a little bit. And now it will tell us the x and the y coordinates. Now, we really didn't care about the y value. You could write it down, but we really don't care about the y value. We really were just asked what x coordinates make these 2 functions, the left and the right side of the equation, equal. So this would be the first value, and we always want to keep at least 3 decimal places. So if you put -0.342, that would be okay, or you could keep extra digits. All right, and let me repeat the process for this second one. So I will go to, I'm going to transfer that to my paper later. So I'm going to go to F5 and choose intersection again. And now I know the answers are function y1 and y2. So you'll get used to very quickly just hitting the enter key twice when you only have 2 functions. And then you'll move to the left side of the intersection for a lower bound and hit enter. And then you'll use the arrow key to get to the right side of the intersection for an upper bound and hit enter. And there's our second x coordinate. Again, you could write down the x and the y coordinate as an ordered pair on your paper. Sometimes you'll want to know both of those. And then I can repeat the process to find the third one. So by doing this several times, so if I do our F5 intersection one more time, very quickly. I already know function y1, hit enter, y2, hit enter, and then I have to move to a lower bound. And the closer you get, by the way, the faster it will be. So it won't say busy quite as long. So get close to the left side for your lower bound, and then move to the other side for your upper bound. And that will be the third x value that makes the left side of the equation equal to the right side of the equation. So let me change windows here. Remember, we simply wanted this 2 to the sine x to be equal to this cubic polynomial. So we've found 3 values of x that make these equal. So I'm going to draw my graph on my paper, and I'm going to list these 3 values, and then I will be back with you. All right, so I've drawn a quick sketch of my window, and notice that I've shown the min and max values for my window, and I've rounded my 3 x coordinates to at least 3 places. All right, so we got one more question, which is a little bit more complicated than the others, but really very quite simple. We're going to put this function, this is the function for the concentration of the amount of medication in our bloodstream. If you are given X milligrams of the drug, so our x-axis will be the amount of the drug, and then our C of X on our vertical axis will be the concentration. So we're hoping to get a concentration of 4 thousandths is our desired value. So let's put this function into our calculator, our Y editor, and look at it first. And then we'll have to choose an appropriate window size. So let me bring back my calculator window. And let me drag it over here a little bit. So I'm going to go to our Y editor, Green Diamond Y, and if I don't want to get rid of these functions, let me do this so you see this. We don't want to graph them anymore, but I might not want to delete them. So F4, you'll notice up here that F4 has a check mark on it. So it's simply like unhighlighting it on your computer. So if I do a F4 key, it took away the check mark. So this is what you would use if we now want to use Y3 without getting rid of the other 2. So we're looking for e to a power, so that's this green value here. So I hit my green diamond key to get e raised to a power, and the power I want is 0.85x. Use your variable key, and close up the exponent. And then we have -1. Make sure that -1 is not part of your exponent. So I'm going to check the pretty print to make sure that I have e to the 0.85. X is in our exponent. And we could go look at the graph now, and we have the same window we had a minute ago. So that window size is not necessarily going to serve our purpose. So what we're interested in here, so we can see the negative side would be meaningless. So the amount of medication you give your patient, the more of the higher the concentration in the blood. And we're hoping for a concentration of 0.004. So remember that 0.004 is very, very close to the axis here. So I definitely want a very small window size here. So I know what I want vertically. I want to zoom in on 0.004. Where do I want to zoom in on the x-axis? Well, I'm sure I want to be in this very, very close area. So I'm arbitrarily, and I kind of am cheating since I've done this problem before. So for my window size, I'm going to have the x-min go from 0 to 0.01, and it might take some trial and error. I just don't want to use up all of our time doing that trial and error process. And then for our y, we know that we want to be around our target of 4 thousandths. So let's graph from 3 thousandths, 0.003, to 0.005. So now it'll be just a very small piece of that curve we saw a minute ago. So now let's go back to our graph, and you'll see it just looks like a straight line because we're zoomed in on a very small piece of what we know is actually a curve. All right, so what we know is that 0.004 is right here in the middle of our screen. So this is what we would like to do. We would like to put this X value for the amount of medication so that our patient right on the nose hits 4/1000ths as the concentration in his or her bloodstream. Well, the chances of hitting that exactly that amount would be pretty slim. But we might say, and that's what the rest of our problem told us, that if we can get within 5/10,000ths, we would be close enough. So let me show you what our idea is here. Let me just draw for a minute here what we're seeing on our calculator, but in an enlarged version. So this is our C of X, and this is our X in milligrams. And what we know is that we would like to hit this, better write it correctly, 0.004. This is what we would really like to hit. But we know that we could cure our patient as long as we get them close enough. So I would want to go 5/10,000ths below and 5/10,000ths above. So there are many times that horizontal lines on your graph are going to serve a good purpose. You might think that it looks too simple, but now the idea is that I know that as long as, oops, that's not very vertical. Let me try redrawing that. As long as I can get my patient to be somewhere within this region, they would have enough medication in their bloodstream to cure them, but not too much. You can imagine if you gave too much medication, it might be toxic or harmful. So I can't hit my target exactly. I would settle for getting between A and B because that would keep me within our tolerance level. So this is going to be an important idea of a limit in calculus. As long as we can get very close, that will be good enough. So now what I need to do on my calculator is simply add two vertical lines and then find the intersection point. So back to my calculator. And I want to go back to our Y editor. And I want to just put in those two horizontal lines. So the bottom one is I remember Y is always a constant, is a horizontal line. So I simply want to put in 0.0035 for one horizontal line and 0.0045 for the upper boundary. And now when I go to the graph, I don't have to do all the algebra. Remember, I'm looking for the X coordinate here to make sure that the patient gets enough medication, and I'm looking for the X coordinate here to make sure the patient doesn't get too much medication. So we find our intersection again. So F5, we've done this before. Oops, I'm thinking this is a touch screen here. Let me try F5. Don't touch the menu, but hit the button. F5, choice 5 for intersection. And now we've got three graphs. So now we have to answer the question, what functions do you want to work with? So first let me do functions 2 and 3. So you'll see how these, my functions are in 3, 4, and 5. So yes for function 3, I'll hit enter. And yes for function 4, so I'll hit enter. And then I'll move the cursor below the intersection for the lower bound and above the intersection for the upper bound. And I already knew what the Y coordinate would be, so this is the X coordinate. So that's going to be my value I'm going to write down for A. And I want to make sure I'm bigger than that value. So there you would want to make sure that you round up. So make sure that you are at least 0.0042, for example, or 0.005 if you're rounding to the nearest thousandth. And then I want to find the other intersection, so I'll go again, F5, choice 5 for intersection. Yes, graph 3 is the first one I want to use, but not graph 4. So now I use the up arrow or the down arrow until we scroll around to get to 5. And then I hit enter. So now I'm using graphs Y3 and Y5. I move to the left side for the lower bound and I hit enter. And then I scroll to the right side for an upper bound. And that X coordinate would be the maximum amount of medication I could give. So that one, to be safe, I want to round down. So we want our answers to be within, it says give your answers to 4 decimal places. So for this one, I would not go to 0.0053. So don't round. Make sure this one you would round down, because going above this amount of medication might be harmful. So I'm going to transfer that to our paper. So I labeled our A and B values here, and I made sure that I stayed above the first one, so I rounded this one up as the bottom level, but the next one I did not round up. I kept that at 0.0052 because we want to make sure that we stay below that value. And that's the idea of staying within a tolerance window.